Hi all. It's a pleasure to talk in front of you today here. Um, my name is Selin Kampa and I work at Siemens Power and Gas Solutions. And in my department, we create digital offerings to our business with newest technologies, from the sales and marketing of a power plant until it's fully constructed. And my job there is to provide solutions with augmented and virtual reality technologies. Before that, I have studied computer engineering and I made a master's in media informatics at RWTH Aachen. And I have been working with AR/VR technology since 2014. Um, I will present you today the motivation behind using these awesome technologies. And I will present a few use cases. And I'll talk about some findings that we have from our developments, our solutions. With AR and VR, we can improve a lot. We can improve ourselves a lot with different ways. It is always amazing to see how we can bend reality and bind information to it to enable more of ourselves. When the information is ubiquitous and we are able to reach the information from our environment, it makes some tasks easier and quicker. It is always nice to reach information, being able to reach information, access information, and also, especially with head-mounted displays that are see-through, we can preserve focus in reality, especially with hands-on tasks, and we can also reach the information. And another important point is that we can have increased spatial understanding, and we can compare what has been designed to what has been built. When we are activating our bodies and when we are moving in our environment, we are activating our senses, and while doing that, we are able to see 3D visualizations. It brings us more energy. We move our bodies, and this makes us better at what we are doing. It makes us more motivated and more productive. Also, with these technologies, we can add haptic feedback and sound to our reality, which makes us as a person more activated. Especially with see-through displays and AR, it is possible to focus on a conversation, focus on our colleague's face without being distracted with a monitor, and we can be present. We can be present in the moment. And this connects us to each other more, decreases communication errors, and we are able to reach out for all the data in the world while we are doing this. These technologies create a new way of collaborating. We have employees from all over the world. They are working on the same project, and they have different locations. With these technologies, it is possible to collaborate independent from time, independent from location in real time. And of course, every single person who tried these devices feels so good that they have a big smile on their face, and it's just magical and it's just awesome. So after talking about the benefits, we can come up with the result that there are some potential usages. Our experts want to provide their expertise from far away without traveling for hours, and the head-mounted displays provide hands-free tasks to be better. We can use our hands with the freedom of having a device on our eyes. And the design decisions are supported with the extended 3D understanding of these visualizations, and collaboration and documentation in real time are other potential usages. I have to base my use cases on real business needs. So my journey of creating a solution starts with finding relevant people internally. Then I have to understand their needs and I have to collect the requirements so that I can create a demo to present them. After presenting, I collect their feedback, and if it is positive, I can calculate investments and I can develop my demo further according to the requirements. Then this feedback loop continues. We follow an agile approach in this. So in each of iterations, we add more functionalities. We collect feedback again from the user, and we continue like that until the product is fully ready and satisfies the customer requirements. Now let's talk about some use cases we have. My first use case is the holographic design review, which is also multi-user. We want to increase the 3D understanding. We want to improve the spatial understanding of our design engineers. And we can do it with holograms. When the high-quality 3D designs are rendered with high-quality renderings, we are able to walk around it. Our design engineers can walk around it and have a full-scale model of their design in front of them. And this way, they can compare what they have designed to what will it look like when it is built. And it is so realistic that they can also do accessibility checks, which means that if some components that are necessary to access are accessible when we walk around the pathways, or if there is an unexpectedly large gap placed on the pathway that a person can fall in when this design is built. And these things, understanding these things gets very much improved with these technologies. As I told before, we have colleagues that work from many different locations. What we target is to have a common understanding on the 3D design from all over the world in real time. And this is the prototype we developed with Microsoft HoloLens to satisfy this use case. It is with multiple users, and the designers are represented as avatars, and their focus is also represented with a laser pointer. I can show you now a video about how this prototype works. Let's continue with another use case. We have customer meetings during the sales phase of the power plant. We have to provide what are the options for the customer and what our solutions. And that is why during the customer meetings, it's always better to have visualizations. But it is even better to have 3D visualizations. And this way, we can give an impression to the customer of how their power plant would look like when it is built, could look like when it is built, and also we are able to answer customer questions better and give more details about power plant better. In this use case, it's better to use some mobile solutions with tablets with simple applications. But it's also an option to use smart glasses. Here is another use case, and it's AR on site. During the erection phase of the power plant, we need to do multiple checks. We need to check if everything goes well, if everything goes as planned, as design world fits to the world that has been constructed. And during this use case, there are two options. One option is to bring the site to the office, which can be done by 3D scanning or remote collaboration. And the second option is to bring the office on site. This can be done by rugged tablets or smart glasses with some safety helmets. Because the environment health and safety regulations on site are pretty strict. And that is why we prefer the rugged tablet solutions better than having fragile hardware. And robust tracking is another important point in this use case. On site, there are changing surroundings, and there is outer condition, there is dust, and for these conditions, it's very important to have robust tracking. From the use cases I presented, and also in general from our developments, I harvested some findings, and I would like to share that with you. First of all, we have complex CAD data, and this CAD data needs to be pre-processed to be able to render it in the GPUs of mobile devices or computers. And this is still manual effort. Still, there is a need of lightweight mobile virtual reality devices that can render high-quality graphics. And cables destroy the immersivity of virtual reality experiences. And as I mentioned before, the robust tracking is very important for an augmented reality application. Having hardware complexity high and weak tracking leads to lower acceptance of the user. Now let's talk about acceptance. This is a new technology, and like every other new technology, there should be time and effort to be adopting this, to be able to accept this in a work environment. First of all, it needs to make our job easier. It makes to make our job quicker, and it needs to provide the necessary functionalities and benefits we require. And the fluency of the app is very important. Unexpected termination of the application or getting tracking lost is the enemy of having a good acceptance. Design. It is important to have an augmented virtual reality application designed for the user. When a person for the first time uses a mixed reality application, they need to understand naturally what to do. The natural mapping of the interactions should be there. And there is a psychological aspect of these applications that people are afraid to make mistakes sometimes. Or it also depends from person to person that some people are not digital natives. And that is why it puts a great importance on how we present this application for the first time to our user. And the people should be comfortable. when the hardware is heavy and they get tired using the application, they just don't want to accept it as much as the other option. So you're introducing a new experience, and it is on the person's head if it's then head-mounted display, for example. It is kind of invading their personal space, and it is completely new reality for them. And that is why a lot to do about the presentation. As I mentioned before, people can be afraid of making a mistake in front of their colleagues. And that is why the presenter should be able to comfort them and convince them that, like every other technology, it is necessary to invest time and effort to train about this new way of interaction. And also, it is important to have clearly identified steps to follow for the user. So when a user first time started an application and they are unsure of what is going to happen to them, something unexpected can happen to them, then they feel less comfortable. So that is why it is important to clearly state how the interactions work and how the steps will be, what will they see. And also, it is important to have the VR and AR space clear from obstacles, and if they get motion sickness or headaches, immediately the presenter should stop them and tell them it's completely normal and they should rest a little bit. And lastly, when a person has a little bit of time to try by themselves, there are some tutorials in every AR, VR device to try. And that is why I sometimes, in some presentations, give them some space to try by themselves, saying that I will be back in 5 seconds, and they just try by themselves, and they are free to make mistakes without being watched. And it is user-centered design of interfaces is a big part of developing an AR, VR solution. It is important to get unbiased feedback of people to the development period. For example, we had a simple application that we use in our sales phase that we place a power plant model on a surface. And it was very simple. The interaction wasn't there yet. It was just a prototype. And every single person who tried it, this movement was there. Like, they wanted to zoom in like this. And now we know that in the next step of this product, we have to also include this interaction. And this way we can base our development on the user needs. In power plants, there is a lot of use of visualizations. Visualizations help us a lot. And AR and VR is definitely beneficial for us. But even though we have complex procedures, there are needs of industrial functionalities. I would like to underline that there is always a big focus on human perception, senses, and psychology. And good interfaces and better applications leads to successful tools, and this shapes the future of industry. Thank you very much for listening, and that's all. So I would be happy to listen to questions and answer them.
Do we have any questions? Oh, over there.
When you go about checking for these types of projects, what type of analysis do you do? Do you check the amount of users within the company, within Siemens, or do you check the customers? We saw a lot of sales tools, but do you use it internally for training as well? There's kind of two questions. What is the process and whether you use it internally?
Okay, so first of all, the use cases I presented are mostly based on internal customers, which means that we are supporting our internal colleagues to be able to do better in their jobs, to improve their work digitally. And that is why, except it can be also external, but most of my use cases currently are internal, yes. And what I do is that at first I need to contact them to find the people internally and see if I can solve their problems with AR and VR. And this evolves based on their needs. If I
Something related to VR?
VR also is a part of our work. I presented use cases somehow mixed, but virtual reality also satisfies some use cases. But it is always based on what the person needs. Yeah.
Okay, any other questions right now? Here, over there.
You were talking about the manual efforts involved in the 3D CAD data. What were those manual efforts to get the 3D data usable on mobiles? So what were the processes?
So the CAD data is very complex. It means that the mesh is very complex. So it's a little bit technical, but to be able to render some models in GPUs, they need to be not millions of polygons. They need to be reduced, and our CAD designs are very detailed. And that is why at first we need to remesh them. We need to make them smaller in the sense of using GPU power. And this means that we need to really work on how to make them again somehow. Convert them and make them smaller so that the devices don't lag and have problems with rendering.
So you made them smaller or reduced the polygon count?
Polygon count.
You reduced the polygon count?
Yeah, that. And also we can split them into pieces, sometimes if it serves the purpose, but every time it's individual cases. So it depends on how the application is. If it is a full plant model, there is a lot of necessity to do a lot of reduction. Yeah.
Thank you.
Yeah, so I'm sort of staying on the CAD issue, I guess. I feel the same way. It's very manual, labor intensive. But what is your specific workflow? Like, what software do you use for converting from CAD to polygon meshes?
Yeah, it depends. So we can catch up on that later if you want to. But, I wouldn't like to really go on technical details. Yeah.
I understand. Thanks.
No problem.
I think here in front of you.
Yeah, can I ask a commercial question? Yeah. So, am I right that you help your internal customers to meet their requirements and technologies? If it's VR and AR, so it's okay. And when it fits their requirements, what goes after that? You find a subcontractor who can provide service, or they find subcontractor who can provide, or you do it internally. I mean, the big rollout project, because company is big, not just to do minimum value project. It can be really huge. So who pays money in your company? I mean, if I subcontractor, who can I come? You or final customer? Business customer.
Look, I'm a technical person, and the budget questions goes to my manager. So, but I can
Sorry
say
for
that
that.
right now my use cases are based on internal customers. So, yeah.
Any other questions? If not, I have one. Exactly the question about how to reduce polygon counts. When you have a PLM system, you have Teamcenter. You just ask Teamcenter, give me the polygon count I need. You're not using that?
It doesn't work that way because
Okay, interesting.
For a device that is mobile, that is
Okay.
having a very limited GPU, I can't have a count of 2 million polygons.
That's clear, but Teamcenter by itself is able to produce lower polygon count of CAD data. Why are you not using that? When it's your tool, you're the manufacturer of Teamcenter, just getting it there. Is there anything which hinders you to do that?
Yeah, I still get them, but it's not enough. That's the
Okay.
problem. The GPUs of the day, is not enough to render these data still. We still need to do that pre-processing every time.
Okay, thank you. Then I would say many thanks for presenting this, and I really enjoyed your presentation.
Thank you.